today what we're going to do is we're going to start our study of trigonometry. Trigonometry just means the study of triangles. Okay, so we're going to study specifically right triangle trigonometry for now. After the air test, we're going to do other kinds of trigonometry, but we're starting with what's called right triangle trigonometry. Long time ago, you know, we talked about Pythagoras, and he discovered the Pythagorean theorem. But he and his friends also discovered more information about right triangles. But we've studied a little bit of that when we studied special right triangles. Remember we did the 30, 60, 90s and the 45, 45, 90s? They found that pattern that happened over and over again. Well, there were more patterns that happened. They discovered that every right triangle that had, for instance, a 90-degree angle and a 42-degree angle, every triangle that had those two angle measurements followed a certain pattern. They figured out every right triangle that had a 37-degree angle followed a specific pattern. Okay? And they found these patterns and they started recording all this data. So what they started doing was comparing specific sides together. They're saying, like, if I compare the opposite side of the hypotenuse, that they would always be in the same ratio. Okay, so remember how we just got done talking about similar triangles? Okay, and we said that the angles are congruent and the sides would be proportional. Okay, so they started recording all of those ratios that were happening because the 90-degree angle and a 42-degree angle, any triangle that has those two measurements are going to be similar, right? Because those triangles are similar by angle. Okay, so Pythagoras and his friends started recording all this data, and they made what are called Trig Tables. This is a one-page trig table, but basically this has angles 1 through, I believe, 89 degrees. Yes, they went up to 89 degrees. 1 through 89 degrees, comparing specific sides from specific angles. Okay, these are all right triangles, so you have to have the right angle as well. This is a one-page table of how they collected all of these ratios. My high school trig book has at least 20 pages of tables like this. Because this has 1 degree, 2 degree, 3 degree, 4 degrees, 5 degrees, and so on, right? Well, what about 1.1 degrees? Or 1.01 degrees? There's a lot of numbers that happen in between 1 and 2. Okay, so it's very tedious. Right? I always had to have my textbook because we weren't allowed to use calculators like we have now. I know that probably makes me sound very, very old, and I kind of am, but we didn't have access to like what you guys have now. Okay, so we use what are called trig tables. So they were always comparing these same sides over and over and over again, and they ended up coming up with names for these comparisons. They called them sine, cosine, and tangent. Okay, so this is sine, S-I-N-E. This is cosine, and then tangent. We abbreviate it as S-I-N, C-O-S, and T-A-N, but we don't say sin, cos, and tan. That makes you sound uneducated, okay? And math is never a sin. Right? Right. Okay, so we say sine, cosine, and tangent, but we abbreviate it as S-I-N, C-O-S, and T-A-N. Okay? All those are just names. You can name them Fred, Bob, and Tim for all that matters. Okay, sine, cosine, and tangent are just names. They're names they represent that you're comparing two sides. So the sine of an angle, meaning coming from a specific place, compares the opposite side to the hypotenuse of the triangle. The cosine compares the adjacent side to the hypotenuse. The tangent compares the opposite side to the adjacent side. Okay, so sine, cosine, and tangent are just comparing specific sides. So Pythagoras and his buddies said, okay, if I'm standing at a 1-degree angle, remember we have to have a right triangle as well, and I compare the opposite side to the hypotenuse, they're going to be in a ratio of 0.0175 every single time. If I compare 2-degree angles, it's going to be 0.0345 every time. They did this for all of these angles. The beautiful thing is, this table plus much, much, much more is stored in your calculator. Okay, so in your calculator, you have a sine, cosine, and tangent button, right? Okay, all it's doing is referencing a table. So if you were to type in, go ahead and type in, well, wait, before we do that, we have to make sure our calculators are in degrees. If you have a scientific calculator, You should see DEG in your screen somewhere. It's either usually at the very, very top or the very, very bottom. Everybody has a scientific, see that? When you reset a scientific calculator, it'll go back to degrees. If you have a graphing calculator, you need to press the mode button, which is right next to the blue second button. And it needs down like 3 rows, I believe. It says degrees and radians. You need to make sure degrees is highlighted. Because all of our angles are going to be measured in degrees. Next year, you're going to learn about radians. It's another way to measure angles. Okay, so everybody in degrees? Okay, so I want to type in, let's just do sine and then of 9. So the sine of 9, that means we're standing at a 90-degree angle and we're comparing the opposite side to the hypotenuse. So what ratio are they always going to be in? 0.1564, right? 0.1564, so, and then some extra numbers. So your calculator can store way more numbers that we can put on this table. Right, so when we press sine of the number, or we do something else with it, which we'll talk about later, it's just referencing a location in a table. It's everything, it's all it's doing. Okay? So we're going to look at, first of all, we're just going to work with some of the ratios. We won't use our calculators for a little bit here. So we're just going to practice figuring out what those ratios are before we put them into practice. All right, so first thing we need to do is identify an opposite side, hypotenuse, and adjacent. We have to figure out what it is for all the triangles. What's going to happen is I'll say like the sine of A. Okay, so if I say the sine of A, that tells me I want to position myself at angle A. Okay, if I position myself at angle A, it kind of gives me a point of reference. So the hypotenuse is always going to be opposite of the right angle. Okay, the hypotenuse will always be opposite of the right angle. Just like when we did Pythagorean theorem. Just like when we did special right triangles. The hypotenuse has to be the hypotenuse. Is that okay? Opposite and adjacent will switch depending on what angle you're looking from. So if I'm positioned here at A, the adjacent is actually part of that angle. So this side here is the adjacent side. And then opposite of it is going to be all the way across the triangle there. So this is the opposite side. The term opposite should not be new to us. Because remember a long time ago we talked about the largest side is opposite the largest angle, the small side is opposite the smallest angle. Okay, so that's the opposite we're talking about. All right, so first I just wanted to practice identifying opposite, adjacent, and hypotenuse. So if we are positioned here, up here at this angle, we're looking at this one here, this has to be what part? This is my hypotenuse. What is this piece? Adjacent, and then this is opposite. Go up to this little skinny triangle on the top. So I'll show you where to position ourselves. What is this little side? Opposite. How about this one down here? Adjacent, and up here, hypotenuse. You do the last two. You take a second and do the last two for me. No, I'm going to talk about that in 1 second. Good question. Anyone need more time? All right, so how about for this guy down here on the left? What's this side? Hypotenuse, this is opposite and adjacent. Last one, what's this top piece? Adjacent, this is, and then opposite. Okay, so Brenda asked a really good question. She said, will we ever position ourselves at the right angle? So let me erase this. Let's pretend, let's pretend he's here. What if we positioned ourselves at that right angle? This is my hypotenuse, right? Has to be my hypotenuse. What side's opposite? What side's adjacent? The hypotenuse is also opposite. And then I actually have two adjacents. Okay, so those ratios don't work when we position ourselves at the hypotenuse. Or at the right angle because we don't have very specific parts for each piece. Does that make sense? That's a good question. All right, so first thing we're going to do is we're just going to compare compare parts. Okay, so we're going to use our three ratios. There's a saying that helps people remember this. The ratios. It's called SOHCAHTOA. Say it, SOHCAHTOA. SOHCAHTOA. So it means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you have, like, people who have been out of high school for years and years will usually remember SOHCAHTOA. Not that they could use it or remember what it's for, but they remember the phrase SOHCAHTOA. Okay, so SOHCAHTOA is kind of a helpful way. I know you can probably still see your ratios on the front of the notes, but that's kind of a way to remember. It's also on the air test for you. Okay, so the ratios are written out for you. Sounds like a place. Yeah. Somewhere sunny on a beach. SOHCAHTOA in the ocean. All right, so what we want to do first is it says find the sine of A. That means we're positioning ourselves at A. If I position myself at A, remember sine is opposite over the hypotenuse. So if I'm at A, what side is opposite? 4. What side is the hypotenuse? 5. Okay, so we're just coming up with the ratios. How about the sine of B? So I'm changing my position. But the sine of B, sine compares opposite over hypotenuse. So it's going to be 3 over 5. How about the cosine of A? So that's adjacent over hypotenuse. So it's going to be 3 over 5. You finish the cosine of B, the tangent of A, and the tangent of B. So finish those last three ratios. Anyone need more time? All right, so what's the cosine of B going to be? 4 over 5, adjacent over hypotenuse. How about the tangent of A? 4 over 3, and then the tangent of B? 3 over 4. Questions about that? At this point, it has no power for us. We're just comparing parts. It doesn't do anything yet. All right, so the next three problems, there's 3 problems on this next slide here. So we're just going to look at one vertical column at a time here. So I kind of blocked off mine. So this has come up in the air test a couple of times here. They're given us that the sine of A is equal to 20 over 29. The sine of A is equal to 20 over 29. They want us to find the cosine of A and the tangent of A. So keep in mind, it says the sine of A, they want us to position ourselves at A, and we know sine compares opposite to hypotenuse, right? So that means the opposite over hypotenuse has to be 20 over 29. The opposite side has to be 20. My hypotenuse has to be 29. Right? That's opposite and that's hypotenuse. Because this is a rectangle, can I find that missing side? How do I find it? Pythagorean theorem. So use your Pythagorean theorem to solve that missing side. All right, what's the length of our missing side? 21. Good. Okay, so now that I know all 3 sides, can I finish these ratios? What's the cosine of A going to give me? 21 over 29 is the adjacent over the hypotenuse. How about the tangent of A? 20 over 21. So if you know parts, you can usually figure out everything else. So you try the next one then. Summary of the tangent of B. right, so tangent of B gives me opposite over adjacent. So that's 7 is my opposite, 24 is my adjacent. What's my hypotenuse going to be? 25. Good. So the sine of B is opposite of our hypotenuse, so 7 over 25, and the cosine is going to be good. Do you think you have it, or do you want to do one more? Anybody want to do one more? Okay. All right, so it's there if you want to do it, and if you want to check how you want me to check it, I can do that too. All right, so the power behind sine, cosine, and tangent with right triangle trig comes from being able to solve for missing sides and angles of triangles. Okay, and that's what we're going to work on next. Again, we've already verified our calculators are in degrees. You want to double check that every time. If you reset your graphing calculators, it'll go back to radians. Okay, so be careful resetting graphing calculators. All right, so we're going to start by positioning ourselves at the angle that we're given. So this time I'm going to position myself here at this 30-degree angle. We got to figure out which ratio we want to use. So the x in this case is what part? Opposite, adjacent, or hypotenuse? Opposite, and the 10 is the hypotenuse. So I wrote our SOHCAHTOA up here. Which one deals with opposite and hypotenuse? Sine. Sine compares the opposite and the hypotenuse, right? So we're going to write, we have the sine of our angle, which is 30, is equal to, I'm comparing opposite to hypotenuse, so x over 10. I just treat this like a proportion and I cross multiply. Do not type anything into your calculator yet. So 1 times x gives me x, and then I have 10 times the sine of 30. Always put that constant out front. Now, I would never ever write it sine of 30 times 10, because it'll inevitably you will goop it up in your calculator. And I'll try to explain that in a little bit, but I don't want to confuse things right now. All right, so this says 10 times the sine of 30. So go ahead and type that into your calculator. Type in 10 times sine of 30. Keep in mind, as you're pressing the sine of 30, it's going back to this table. It's going down to the 30-degree angle. It's looking in this sine column, and it's recognizing that this ratio is 0.5. Right? So it's taking 0.5 times 10. Is that our number? Forget. Yeah. 0.5 times 10, what did you get? You should get 5. Now, this one should have been a surprise to you, because this is one of our special right triangles. It's a 30, 60, 90. Right? The hypotenuse is 10, so the short leg had to be 5. Kind of did that on purpose. That way I'm trying to make a connection. Like, those special right triangles are still true, but those only deal with 2 very specific triangles. Trig deals with everything. All right, so let's look at the next one. Let's look at the next one here. So I'm going to position myself at the angle I'm given, which is the 36. What is the 12? Opposite, adjacent, or hypotenuse? Opposite, good. And what's the x? Adjacent. Which one of our ratios is opposite and adjacent? Tangent. So we have the tangent of 36 equals opposite over adjacent. Okay, so I'm going to cross multiply. So I'd end up with x times the tangent of 36 equals 12. Keep in mind, tangent of 36 is just some number in a table, right? So I need to divide. I need to break up that multiplication. I need to divide by the tangent of 36. So in my calculator, I'm going to type 12 divided by the tangent of 36. What do we get? Yeah, I got 16.5. So this side length here is 16.5 units long. One of the nice things about this is you can kind of check the reasonableness of your answers as well. So I can solve for this missing angle and get 54 degrees, right? So I know there's 180 in every triangle. Take away what I know. Okay, so remember how we just talked about like the largest sides opposite the largest angle, small side opposite the smallest angle? Well, this 54 is bigger than 36, so this side should be bigger than the 12 I started with. And was it? Yes. So we know we're probably on the right track. We probably used the correct ratio. Good? All right, let's try another one. So over on the left here, we're going to position ourselves at 54. What is the x? Hypotenuse, what's the 10? Adjacent. So what do I want to use? Cosine. So we have the cosine of 54 equals adjacent over hypotenuse. So go ahead and cross multiply and solve. What do we get? You should have 17. So you had to type in 10 divided by the cosine of 54. You should have, it's like 17.01 or something, right? Okay, so that ended up being my hypotenuse. And my hypotenuse ended up being longer than the leg I started with. Yes. So probability, okay. All right, you try the last one then. Anyone like more time? All right, so which one is this going to be? Sine, cosine, or tangent? This is cosine because I have adjacent and hypotenuse. So the cosine of 61 equals adjacent over hypotenuse. Cross multipliers, I need to multiply 15 times the cosine of 61. I had 7.2-ish, right? Am I right on that? Okay. Okay, so we can check our reasonableness of our answer here in two different ways. One, we started with the hypotenuse, and 7.2 is smaller, right? The other thing I noticed is this is really close to a 30, 60, 90 triangle. It's not perfect, but it's close. So if I were to go from the hypotenuse to the short leg, I would need to divide by 2. So it'd be approximately 7.5, 7.5. And we got that, right? Because it's not perfect, but it's close. So again, you kind of, with all the stuff you know now, you can start checking, like, does my answer make sense? And I think it's kind of cool. All right, so now that's solving for sides. Next, we're going to solve for angles. Okay, now we're going to solve for the angles. So we're going to position ourselves at the angle that we want. So I'm going to position myself here at x. So the 13 and the 16, what parts are those? Opposite adjacent. Which ratio? All right, so here's what it looks like. The tangent of x, which are unknown, is equal to opposite over adjacent. So what we're going to tell our calculators to do is 16 divided by, hold on, what's it? 16 divided by 13 is 1.230769231. So in a second, we're going to tell our calculators to go to that table. Go to that table, and in the tangent column, right, which is the third column here, we need to find the ratio. So in that tangent column, we need to find the ratio that's 1.230769 and so on. So I would go down my list. Okay, I'm down to ones, right? So now I need to go to my, slide it sideways, please. Please go sideways. There we go. Okay, so now here's my tangent column again. Those numbers are too big. It's looking, it's finding. So it's 1.23. Oh, gotta go a little bit more. 1.2307. So it's got to be between 50 and 51 degrees. Okay, and I just had to figure out which one is it closer to and make an estimation that way. My table is a little bit more specific than I had in high school. That's what we're going to tell your calculator to do. We're working backwards. We're starting with the ratio, working backwards to find the angle. Okay, in math, inverses are working backwards, right? Division is the inverse of multiplication. Subtraction is the inverse of addition. So we are going to use the inverse tangent in order to find our angle. Okay, so that power of -1 means inverse. So if you see your sine, cosine, and tangent buttons, above each of those, you see sine to the -1, cosine to the -1, tangent to the -1. We're working backwards. So you're going to press second tangent and then tell it the ratio, 16 over 13, and hit enter. What do you get? $50.9, right? Which I said is going to be between 50 and 51, right? So obviously this is way more specific. Finding the angles is the easiest. Like you don't have to cross multiply, you don't have to figure out where you're multiplying or dividing. Okay, so let's look at this last one here. Positioning myself at x, I have a 12 and a 22. What parts do I have? Opposite and hypotenuse, which is which ratio? So we have the sine of x is equal to 12 over 22. So we want to do the inverse sine of 12 over 22. I don't care if you write out this last step or not. Right now, I'm trying to help you make sense of things, but honestly, I would write this that first step and then probably do it. What do we get? 33.1 degrees. Is that okay? Which is really close to that special right triangle again. So think about that. Going from the hypotenuse to the leg, the short leg, will be divided by 2. And I'm pretty darn close, right? Great, it's not perfect. But again, I can check, is my answer reasonable? All right, so we're going to be focusing on right triangle trig for the next, I would think, 3 days, 3.5 days. Okay. Tonight's homework I have for you on the front is just dealing with ratios. On the back, I have 8 problems where you're solving for sides and angles. Tomorrow, all we're going to do is solve for sides and angles. On, I don't know what day it is, Thursday? Tomorrow, Sunday, right? On Thursday, we're going to kind of play a game. We'll solve for sides and angles. Okay, on Friday, we're going to take a quiz on this. We'll solve for sides and angles. The ratio. All right, so on the front, you're just doing ratios. You might have to solve for a side so that you can use the write a ratio, right? Using the diagonal theorem, but you're not solving for missing angles or anything. On the back is where you're going to use your trig ratios to solve for missing sides and angles. All right, do your best. We'll recover whatever we need to tomorrow, and we'll keep practicing. Sound good? All right.